Okay. Do you see what's going on? When this plugs in, I need to access.
Is it the that it's zoomed in?
Yeah.
Try out window.
Window. Let's see. No. Maybe I might have to go to settings.
Right. So in display.
No, that's not it. Display, displays? Yes.
Try scale. I'm sure.
Yes, scaled. About to change the display mode. Did that do it?
I think.
Yeah. Okay.
Like
confirm. Okay. So I think everything is working.
All right, perfect.
So,
calls if you need questions.
How do I call?
There is a number posted.
Okay. Gotcha. Probably near a phone or online.
Right.
It's okay. I'll find the source. All right. I think I have this recording. I'm using the Hangouts on Air YouTube service. I don't know if he went over that lecture yet, but hopefully I'm using it correctly. If not, then I will not be doing my job very well, but it says it's broadcasting. Okay, great. All right, so, all right. I am a PhD student here, and my name is Sam. First, I will talk about my research a bit, and then I will go over what LaTeX is. So actually, I'll get a head start on the LaTeX part. Here, the window that you're looking at is LaTeX. It's not my research. So what I do is reinforcement learning, which is a branch of artificial intelligence that deals with the process by which an intelligent agent learns how to act and behave in an environment from its experiences. So over time, it interacts with an environment and gets rewards, and then learns how to maximize those rewards and how to optimally perform. So an application of that would be in self-driving cars, for example. You can have a driving simulation, and the car can be rewarded for not hitting pedestrians and not leaving lanes, and then it'll learn to work within that simulation, and then it can be deployed into the real world. Alternatively, you can have reinforcement learning in video games. So you can have a character in a video game that is an artificial intelligence that learns to maximize whatever its objective is. So it could be a simple game like Pong, or it can be more complex games. Today's state-of-the-art, latest reinforcement learning algorithms can play really complex strategy games, 3D games. So these technologies are capable of doing a lot today. They can learn locomotion, they can learn strategies. So that's something I'm interested in, and I'm interested in getting an agent to be able to contextualize between one domain and another. So namely, that would be general intelligence. And that's my research area. So yeah, I guess I'll go into what LaTeX is now, because that's what this lecture is going to be about. Although I think Rolando might have hinted that there might be a question about my research at some point. So just to reiterate, I do reinforcement learning. And that is the process by which an agent learns from experience in some artificial environment or the real world. Okay, so LaTeX is a programming language. Right now you are looking at a website. This isn't LaTeX. The LaTeX part is just this text here. That's the language. The rest is just a convenient website for displaying what this language generates. So on the right side, you have a document being generated by this LaTeX code. And LaTeX is a programming language for generating complex formats in research papers or textbooks or documents. So it's very useful for that sort of thing, especially if you have to deal with math or figures or any kind of formatting specifics that would be really tiresome with Microsoft Word or some other text editor like that. So yeah, this on the right side is a presentation made by another PhD student named Brian, but I will be presenting these slides. These slides are programmed in LaTeX. So this code generates these slides, but normally when you see LaTeX, it'll look more like this as it loads. So this is a paper that I wrote a while ago. But yeah, it's a research paper. So yeah, I'm talking about a programming language called LaTeX, which is used for creating pretty documents and research papers and reports, or writing textbooks, or making presentations. But normally, if you're doing research in an engineering field or a math field or physics, you'll be writing a lot in LaTeX. So if you want to go into research, you'll be using LaTeX to make documents like this. So LaTeX, so in Microsoft Word, you'd have to like hand code, you'd have to like manually make all of these formatting details. And that'd be really annoying. So LaTeX handles all this for you, and it's the code for it is pretty simple. So we'll be going over the code in a moment, but as you can see, LaTeX can generate algorithms, or you can add figures. Let's see if I can find some math or references. Yeah, it's just or math. Doing something like this in something like Microsoft Word would not be fun, because you'd have to, find a symbol like this, and you'd have to, so LaTeX helps with writing research papers or reports or creating slides. So in the case of slides, these slides were created in LaTeX. So just to show you that, all right, so just to emphasize, this is a website called Overleaf, but you can use any LaTeX editor. You can use Share LaTeX or latexeditor.com if that's, I don't know if that's a real one, but yeah, so this is just a website for generating that language into that pretty presentation. So the LaTeX part is just this code over here. And that's what we're going to be learning over the course of this lecture. So just to show you that this is a programming language, I'm just going to change the theme of this presentation and then recompile. And then, yeah, so the presentation looks completely, is just a different theme now. So yeah, I don't know if I should go with this theme or the other theme. I think I like this theme more. So yeah, I'm gonna put a strike through next to Brian's name because I think now it's my presentation. Let's see. LaTeX strike through. So oftentimes I don't remember the syntax for LaTeX code, so I'll just Google it, and usually the answer is pretty clear. In this case, I don't know if it is. Looks like it's -st. So I'm just gonna do that around Brian's name. I hope Brian wouldn't be upset about this, but yeah, so let's see if that worked. Nope, recompile. Strike through, where did I go wrong? I don't know. All right, you know what? I'll make Brian's name not italicized. Okay, and I have an extra symbol here. Okay. So yeah, you can modify code like that. I just got rid of a text it symbol, which italicizes code. I think strike through is /st, and then, yeah, I don't know why that didn't work. Okay, that's probably for the best. All right. So I'm going to download this presentation now and actually present it. But hopefully you get the idea of what LaTeX is. It's a programming language that generates reports or presentations, and you can modify the formatting by modifying the code. Okay. So yeah, this is basically what I said. This is why you would use LaTeX, because it can help you stylize pretty documents. It can help you keep track of references and all sorts of different formats, especially math. It's very convenient for math, for physics and engineering. It's not like Microsoft Word, because Microsoft Word isn't a programming language. It's just an interface. So being able to do certain formattings with an interface requires a lot of mouse clicking and dragging. This has just default code that you can add. And the other reason it's not like Microsoft Word or these other editors is because you wouldn't be writing a research paper in Microsoft Word simply because that's not standard. LaTeX is more standard in the research community, so you would be using LaTeX for that reason if you want to do research. Yeah. But if you don't want to do research, then maybe a motivation would be that you can make pretty stylized reports and documents. So yeah. So yeah, you can import different packages that enhance the functionality of LaTeX. There are math packages, graphics packages, and you just add a \use package. So yeah, as you saw in the other example, or in the actual code for these slides, there was a header that consisted of a title, a subtitle, author, the institute, and the date. This is all you have to do to include that header. You do a \title, \subtitle, so on, and then it generates, yeah, that header. So yeah, then you have the body of the document, which starts with a \begin and ends with a \end. You can divide the document into sections using section and subsection, and those would be numbered. If you want them to be not numbered, then you just add an asterisk. So yeah, so far, hopefully clear, but if anyone has questions about what LaTeX is or the syntax that I've shown so far, yeah, just feel free to ask. So we're going to go into how to make lists in LaTeX. This is how you make lists in LaTeX. You start with a \begin and itemize, and then for each item in the list, you just add a \item, and then this is what's generated. So you begin a list by beginning itemize, and then you have items, and those items are generated. So that's how you make lists. To make numbered lists, instead of itemize, you write enumerate, and now you have a numbered list. This doesn't have a strike-through example, but if you want to do italicize, if you want to do italics, the code is text it, or underline, or text BF for bold. So that's how you format text. Yeah, and if you want to include math, you can do it in two ways. Usually you would just put $signs around your math, and it'll make that math, it'll give that math a nice, pretty format. Or you can use begin and end equation, but you could just do something like x = 5 and then put $signs around that. And then that x = 5 would look different from the surrounding text. So yeah, you can also, right, you can have inequalities and multiplication symbols and division symbols, and these are the, you would just do a \times if you want to insert a math time symbol. And then if you want to insert all these Greek letters, you just do the \ and then the name of the letter. So if you want to do a fraction, here's a good example of math now. You have $2 which indicates math. Then you do a \frac for the fraction, and then the numerator and the denominator. And this gives you 3/4. So in Microsoft Word, it wouldn't, you'd have to figure out how to make something look like this. Here, you just code it like that, and it appears like that. And then more complex math. Also, in LaTeX, not that hard to do. This would take me a while to figure out how to do in Microsoft Word to style it like this. So this is where LaTeX excels. First, you define that it's a fraction. You have x equals a fraction, and then that fraction starts with the numerator. So you have negative b plus or minus, which is backslash pm, and then the square root, and so on. And then your denominator is 2a.
You would need dollar signs around them, or was that just?
Yes, you would need. Or actually, in this case, this is a different kind of. Normally, dollar signs would be used if you're putting math inside text. Like if I were to put an equation here between in the middle of a sentence. So here, here you have to enter a different mode. So yeah, here you can't do dollar signs, but you can do the begin equation and end equation. Yeah. But I could insert math into a sentence like that. And that's how I would put math in the middle of a sentence with dollar signs. So yeah, similarly, you can do summations with a backslash sum. Notice that this summation also has variables under it and above it. So that's where this base symbol is. So you have sum base n equals 1, n equals 1, and then the exponent symbol for infinity, backslash infinity. So that's how you do a summation, and so on. So yeah, styling something like a summation in Microsoft Word would also be really hard. So, or really inconvenient. So that's really where LaTeX excels. And yeah, creating a table is not too hard. You start by doing backslash begin tabular, and then within that tabular section, you define your table. So yeah, in this case, he defines a special kind of table that has a line, a vertical line going through it. That's what this is. Yeah. And then these indicate new rows. The double backslashes indicate another row. So you have 2 and 3 and 4, and then double backslash to go into the next row. Okay. So yeah, this just explains that.
There's some other platforms that you can use LaTeX in, because right now Overleaf and shared LaTeX are both totally broken.
They are?
Yeah, well, because you have to merge the accounts because of Overleaf v2.
Yeah,
so you
yeah,
get
yeah.
stuck in this loop of like trying to confirm on both ends, so like I can't access either of my
Oh
accounts.
no, I see. Yeah, they're updating to V2. There might be like, honestly, sharelatex.com might be a real thing. But I don't know. I would just Google it. I use Overleaf v2. You technically don't need a website or a platform or any interface. You could just compile. You could just write your code in an editor and compile it with their special compiler. But that's harder to do. I prefer to use a website. Oops, I wrote share LaTeX and then LaTeX editor. Okay. I don't know. This one's ugly though. Oh well. Sorry.
Experience is clear, yeah.
You can port your account from one or the other to V2. All right. Yeah, you can insert figures as well. Begin figure, then you have a caption and centering to center the figure. And then you can define the size of the figure. So yeah.
For the figure, like how does it know like what image it needs to use? Like
Right. So somewhere you include a link to the figure. Let's see how that's done. So the nice thing about LaTeX is that you don't really need to memorize it. You can kind of just look up things as you go along. Because I've been writing research papers for a long time and never really needed to memorize every detail of the language. So you probably can get away with that. Should I look up centering? Oh, okay. So I think it's this label, figure A, which might be defined somewhere.
you put it in a folder to the left of this thing. So you would just like save it.
Yeah. Yeah, you would save it into a folder and then link to it somehow. I think probably fig:(A). It's probably, let's see what's in this file. Okay, there's one figure.jpg. So let's see where figure.jpg is. I lost connection. Oh, that means this recording probably stopped. Okay, hopefully not. Nope, it looks like it's still, YouTube is still broadcasting. Okay. Yeah, interestingly, I can't find figure.jpg anywhere. Oh, I think the figure dot is enough, and then he does, and then no, that's this sentence. I'm not sure. I'm sorry. Yeah, I'm not sure. That's a good question. This is how you would add footnotes with a / footnote. And then, yeah. So then you would put your text into where these, yeah. Okay, so citing tables and figures. So before in that figure there was a / label, I think. And you can use that to cite a particular figure. And the same thing goes for any references that you have. So if you have a bibliography and you just include a / cite and then the name for that reference, then it'll add whatever number reference that is to the text. So that would require a separate file where you include all of your references, and that separate file would be would have this would be ended with .bib. Yeah, and then it's convenient because you put all your references into this file, and you can just cite them by name instead of having to always keep the ordering in one way. You can dynamically add new references, and it'll just add the number as needed. This is what a reference looks like in a .bib file. Pretty straightforward. Title, author, year, publisher. And that's what they look like. So yeah, these are the actual references for this slide, for this presentation, which means that we learned LaTeX. Yeah.
When the bibliography, is that a hyperlink? Like, is it a hyperlink within your, can you like click on that? Or is it, okay.
This is a PDF, so yeah. Yeah. So yeah, I guess any questions? I don't know if I'll be able to answer them, but yeah, most things with LaTeX can be Googled. So let's go over figures. LaTeX figure. So this uses a package called include graphics, and it has a figure, it has an image somewhere in its files called universe. Brian did not use that package, so I think he used something else. Alternatively, I could end class, but let's figure this out.
it looks like it begins like.
Oh,
here.
yeah, he does use that graphics package that we just saw. So here's include graphics, and then the title figure, and then here there's a file called figure.jpg. So this, yeah, so if I were to like change this to image, and then I were to change this file to image.jpg, hopefully that would still work. So yeah, that did work. And then if I make the names different, then it should fail. Yeah, well, yeah, so it didn't insert a figure this time. So yeah, that's how you insert a figure. All right. Yeah. If no one has any other questions, then I think that's all for the lecture. Okay, cool. Thank you. Thank you.